Welcome to Module 8. In this module, we will deep dive into our main course project. We will go over the following. We will look at what is a graceful tree. And finally, we will deep dive into our Graceful Tree Stateless Application project to get you started with APIC REST API integration. What is a graceful tree project? Images below are examples of graceful tree. Any data you can represent in a visual/graphic way with a hierarchy of a parent-child relationship is an example of graceful tree. We will use the D3 charting library's graceful tree and modify it to our use case. This is an example of a D3 graceful tree. Our graceful tree project has a copy of this D3 graceful tree example. It is already modified to our use case. Before we start coding, let's review our use case. Our graceful tree project will visually display a hierarchy of tenant and child relationship. We will first deploy the graceful tree project in the Apps tab of APIC. Because there is not one specific tenant context available in the Apps tab, our HTML page will show a tenant dropdown. Once a specific tenant is selected from the dropdown, the page will refresh and use that tenant as the active tenant context. The graceful tree will then refresh and fetch data from APIC. Starting from the top and going down, we have a tenant. Tenant has application profiles. Each application profile has a number of EPGs. Each EPG has a number of EPG members, and it goes on. We are visually showing a hierarchy of tenant and child relationship. We will next modify the insertion URL parameter in the app.json file of the Graceful Tree project, recompile it, and deploy it to APIC again. This time, the Graceful Tree will be accessed in the Tenant tab, where we will inherit a specific tenant context. Because a specific tenant context will be available, we will not see a tenant dropdown at this time. The HTML page will inherit and show you the same graceful tree by using the available tenant context. Our use case will show us how APIC REST APIs are used, how we use JavaScript to make REST API calls, how to reuse APIC cookies, how to inherit and use a tenant context within the APIC HTML page, and how to use insertion URL parameter to modify where your stateless application iframe lives and shows up on the APIC webpage. Let's open our starter Git repo ACI directory we copied to Nginx in Visual Studio Code. As we have seen before, we have three main directories: legal, media, and UI assets. We will spend most of our time in the UI assets folder. Let's open with app.html. We see basic CSS style sheets, some JavaScript included. I have added a debug flag. There is only one purpose for this flag: to tell the HTML page that it is running in our local development environment and outside of APIC. By running outside of APIC, we lose the APIC refreshed cookies. If we were running inside APIC iframe, APIC would take responsibility of managing cookies for us. But when we run locally on our development server outside of APIC, there is no APIC to refresh our cookies. This forces us to refresh our cookies ourselves, hence the use of this debug flag. When the page loads and detects the debug flag to be 1, it performs the following tasks. It makes a login API call to APIC, updates the cookies, populates the tenant dropdown, and calls the init function, which initializes D3 graceful tree object. Let's see an example of it. When I run it locally in Nginx and pass a debug flag of 0, there is no tenant dropdown populated and there is no login API call made. If I go to the Applications tab, I am not seeing any cookies as well. If I change the debug flag to 1, I am seeing a login API call here. and I see the cookies also set up. After it logs in, it makes the API call to retrieve all the tenants, and this populates the tenant dropdown. At timed intervals, it keeps on refreshing the cookies. Every time we make an API call to APIC, the cookies are refreshed and valid. Let's take a look at our API.login function. We are passing in our APIC admin login credentials to the APIC Login REST API. If we are running in debug mode, we set a recurring timer to continuously refresh our cookies containing APIC authentication tokens which have time-based expiration to them. API.post method calls API.request, which builds the complete REST API payload with proper URL and header objects, and makes the API call to APIC. Make sure to change the APIC username and password to match with your local APIC admin credentials. If you don't make this change, you will not be able to test it locally in your environment. Let's get back to the browser and continue our analysis of the graceful tree. If I select a tenant, it passes the active DN and does a page refresh. Now, say I select Application Profiles. It makes an API call to APIC and retrieves all the application profiles and shows them here. I can keep on expanding these and make an API call to retrieve all EPGs. Our sample project does not have the API calls to retrieve all the EPGs. As a learning exercise, we will be modifying our graceful tree project and add the APIs to retrieve the EPGs and build a tree like this. Let's take a look at the API.js file. This file has all the code for making REST API calls to APIC. getTenant retrieves all the tenants from APIC. We will be adding a new method here to retrieve all the EPGs. But we have to know the parameters to pass it. For this, we have to go back to APIC and see what APIs are used. Let's open the API inspector. As shown in Module 2, API Inspector is a handy tool that shows all client-side JavaScript activities that call REST APIs. This will help us get a better understanding of the APIC APIs. I have rearranged API Inspector at the bottom for a better view. Let's go to the Tenant tab and see what APIs are used. This is the API call JavaScript made when I went to the Tenant tab, and this is the response object. To have a better view, let's render it in a better JSON format. As you can see, the actual response data is given inside the IMData object, and all the attributes are within the Attributes Collection object with the fvTenant JSON object. Going back to Visual Studio Code, this is the same API call we make to retrieve all the tenant objects. When we make the API.get call, it eventually calls the API.request, which constructs the URL and all header objects. Another way to look at the APIs is to go to the JavaScript Debugger tab of your browser. I go back to the Tenant tab, and I see the same API being made here. So we have two ways of viewing the REST API interaction between the client-side JavaScript and the backend server. In Module 4, you were introduced to developer resources, and one of the document links was for Cisco ACI REST API Configuration Guide. This document provides you detailed description and documentation on Cisco ACI REST APIs. Make sure to spend time reading this guide to have a thorough understanding of ACI objects, concepts, and available REST APIs. As a developer, you can also use Postman to test with Cisco ACI REST APIs. You need to pass in the two HTTP header objects with valid ACI cookies from your browser in order to test the APIs. You need to copy the values of these two cookies and pass these as header objects. This will make sure your cookies are not expired and they are valid when you make the REST API call to APIC. Going back to Visual Studio Code, if you recall, we need to figure out a way to make the APIC REST API call and get all the EPGs. Let's see how we can figure out what API call is needed for this. Let's switch back to APIC. I am going to pick Tenant Demo and use it as an example. As I expand this tenant, I see that there is one API call made to retrieve all the application profiles. Now let's expand the application profile to retrieve all the EPGs. Here is the API call we need. So we need to pass in the DN name of the tenant object and the unique name of the application profile. Let's copy this URL and bring it into our Visual Studio Code. As we saw earlier, the API.request method is responsible for making the actual URL. We just need to pass in everything after the API call here. So we need to pass in two things: the DN name of the tenant and the application profile ID. I am going to copy this code and reuse it to get the EPGs. I need to replace everything within this API call. I still have to pass the parameter of the application profile here. And this creates my new API call to get all EPGs. Now we have to link this API call when we expand an application profile Graceful Tree node object. Let's go back to the app.html file and review the tree node click function in detail. This function is called every time a tree node is clicked. The goal of the function is to minimize your dependency on knowledge of D3 and Graceful Tree JavaScript file. So this function tries to abstract away the inner workings of D3 code and lets you work on minimal JavaScript objects, so you can focus on building a simple API interaction between your JavaScript code and ACI REST APIs. Main things to keep in mind are: every time a Graceful Tree node is clicked, this method is called. A node is expanded only once. Every node has a type attribute assigned to it. Tree.addLeaf function visually adds a new node on the HTML canvas. And based on the specific ACI REST API call, we may save certain attributes with the node. For example, a DN attribute to specify the unique tenant identifier, or an API ID in case of an application profile. Every time a new node is added to the tree, updateMap function is called. This function serves only one purpose: to reduce complexity of your code. As I mentioned before, you don't need to understand the complexity of gracefultree.js. Instead, just by keeping track of unique node identifier, which is stored in newNode.viz.v, which is an auto-incremented integer ID, you set, modify, and access variables, names, and IDs of your ACI-related objects. This keeps a clear line of separation for you and hopefully makes this code easier to understand as well. Switching back to the browser, let's see this in action. Every time a node is clicked, gracefultree.js calls the treeNodeClick function, passing the click node object. Inside the treeNodeClick function, I retrieve the node object, where I can store my own attributes and IDs, as I mentioned before. And I check on the type of node clicked. In this case, I click on Application Profiles node. It calls the REST API to retrieve the application profiles based on tenant's unique DN attribute. Once the API call is made, it retrieves all the profiles. It has 2 application profiles retrieved so far, and all the attributes are within this JavaScript object. I click on an application profile node. Again, it calls the treeNodeClick function, and add the new nodes of type EPGs. Let's go back to app.html and add some fake nodes to show how easy it is to add additional nodes. I am going to copy this else-if block and add some new fake nodes here. Save this and go back to the browser. Refresh the page. Click on the application profile. Add the EPGs. This time, I wanted to stop here. I click on the EPGs and it adds a fake node. Let's add 2 more fake nodes. Going back to app.html, save it. Now go back to the browser and refresh the page. And here we go. Let's go back to app.html and add a real API call to retrieve the EPGs. This else if block retrieves the EPGs by calling the API.getEPGs function, passing in the DN of the tenant and the app ID of the application profile. Let's see it in action. I am getting an error here which says unable to locate open WebSocket. It's talking about a subscription request failed. This happens when we make the REST API call to APIC with a subscription flag set to yes. Let's go back to our api.js file and see how we can fix this. When we make the REST API call to retrieve the EPGs, we are passing a parameter here which says subscription equal to yes. Cisco ACI REST APIs support creation of subscriptions to detect lifecycle changes of ACI objects. For example, when an object is created, updated, or deleted, events can be raised and sent to client applications that subscribe to those events. Usage of subscription requires WebSockets creation in our JavaScript code. Since our focus in this course is to learn basic usage of Cisco ACI stateless applications, we are not using WebSockets. We had set a subscription flag to yes in our URL, but did not create any WebSockets to manage it. This is the reason why we got this error message. We will simply set the subscription flag to no and continue working with our project. Let's go to the browser and do a refresh. In this case, we have retrieved the EPGs and we have 3 EPGs here. Looks like I have a typo in my function call. Let's fix that. I need to change this D to the variable click node. Save that, go back to the browser and refresh the page. Repeat the same process again. And here we go. Now we have retrieved the EPGs. Let's package and deploy our application to APIC and see it in action. For that, let's go to a terminal window and navigate to the Tools directory of ACI, where we installed the Python library. Now we have created a new application which is ready to be deployed to the ACI. Log into your ACI and go to the Apps tab and add a new application and do a submit. It is now installed to the application APIC. Because I did not specify the insertion URL specifying the exact location of its placement, it is opening by default within the Apps tab. Now let's specify the insertion URL parameter in the apps.json file and try to display this stateless application within the Tenant tab. I go back to the Visual Studio and open app.json. The insertion URL defines the location where you want to display your stateless application. How do I know this parameter? Let's go back to the browser and see how to retrieve this information. If I click on Show Debug Info, it will show the identifier of your current HTML DOM object in the status bar of your browser. For example, if I go to the Tenants tab, it just changed the layout information at the bottom of the screen. If I go within the Demo Tenant context, I am currently within the dashboard, and this changed the URL parameter based on the tab I am currently in. It changed that to center:(B). Let's recompile our application again. We go back to APIC and redeploy it. Go to the Apps tab. We could completely delete this application and add it again. I will repeat the same steps and enable it. Now this time, it tells us the application is deployed within the Tenant tab. And here is our application. This time, the Tenant dropdown doesn't show because it inherits the default context of the tenant object and only shows us information about that tenant. And if we open this in a JavaScript debugger console, we can see the HTML content and the parameter passed to it. Now it is passing the parameter dn equal to dn attribute of this tenant, and hence the dropdown of the tenants does not show anymore. Let's do a quick recap of what we have learned so far. How to interact with ACI REST APIs. How to reuse APIC-provided cookies. How to develop and test stateless applications locally on our laptop using the debug flag to specify that the HTML page needs to manage and refresh APIC cookies on its own. How to control where a stateless application resides and displays within the web page of APIC. And how to use Cisco Python library to package our application for deployment to APIC. This concludes Module 8. In the next module, we will learn the process of packaging our application for deployment to ACI Marketplace.